Okay. So last day before yesterday, you didn't attend the class. Now that's why I'm asking.
Yes, I'm little cool. That's right.
Hi, Samita.
Good evening, sir.
Good evening, ma'am. In last class, we discussed about the chemical equilibrium. Now, today we are going to discuss about the ionic equilibrium. Okay. So today we are going to discuss about here ionic equilibrium. Ionic equilibrium. So what is mean by the ionic equilibrium means here the equilibrium exists in between two ions is called as a ionic equilibrium. What is mean the ionic equilibrium? Ionic equilibrium is nothing but here the equilibrium is exists in between two ions is called as a ionic equilibrium. Okay. Now, so before going to the ionic equilibrium, so that means in ionic equilibrium we are going to study about here acid and bases also. Okay. So because of acids also they undergoes the ionization with they form as ions. Bases also they undergoes the ionization with they form as a ion. So based on acid and bases also sometimes they're asking the questions. Okay. Now first of all, acid and base. So what is mean by the acid? So what is mean by acid? So what is mean by the acid? All of you are getting my voice or not? First of all, tell me, ma.
Yes, sir.
Okay. So because of
Yes.
I think so I'm having little bit network issue. Net is very slow. It is that. But here acid and base. So generally, so what is mean by the acid first of all? What is mean by the acid? So what are the characteristic properties of the acid which we studied in the lower classes means here? Acids are sour in taste. Acids are sour in taste. Okay. The substance here and they convert the pH. Okay. They convert the blue litmus paper into red litmus paper. Is it correct here? So acids are sour in taste. Okay. They convert the blue litmus paper into red litmus paper. Okay. And the pH range of the acids is so 1 to 6. Generally, we can call as a 1 to 7 less than 7. The pH of the acids is here less than 7. Sir, how you are telling that means based on the pH values, we are telling that acids here. If the pH value is less than 7 means that also we can call as a acid. So that is a common definition we know about that one here. So that we studied in the lower classes. Okay. Actually, so different scientists what they had given as a different definition for the acids. What are the different definition means? We have a Arrhenius acid. So which scientist means here? First of all, Arrhenius acid. Arrhenius acid. Arrhenius acid. So what is meant by the Arrhenius acid means? According to the Arrhenius scientist, the substance which releases the substance which releases the substance which releases H plus ions in aqueous medium is called acid. Okay, the substance which releases the H plus ions is called as a H plus ions in aqueous medium is called as a acid. Whatever the H plus ions it is releases, it does not comes outside in the form of H plus. Sir, how it is coming outside in the form of means here? They comes outside in the form of H3O plus. H3O plus only we can call as a hydronium ion. That is only we can call as here hydronium ion. Okay. Here, so based on this one, so what are the examples of the acids? Based on examples of the acids. What are the examples of the acid here based on this statement here? HCl, all mineral acid. HCl, H2SO4, HNO3, HNO3, HClO4. Okay, so all these are the examples of the acid. We can take as a formic acid, HCOOH. Okay, again, we have a two types of the acids. How many types of acids are there here? So we have a two types of the acid. Okay, so what is the two types of the acids? Means we have a strong acids and weak acid. So what is meant by the strong acids? Mean the substance which it undergoes to the complete dissociation is called as a strong acid. What is meant by the strong acid, my here? The substance which it undergoes the complete dissociation is called as a strong acid. The substance, the acid which it undergoes to the partial dissociation is called as a weak acid. Okay, so we have two types of the acid. So what are the two types means here? One is called as a strong acid and one is called as a weak acid. What are the examples of the strong acids? Means HCl, H2SO4, HNO3, HClO4, HClO4. So all these are the examples of the strong acids. So what are the examples of the weak acids? Means here HCOOH, acetic acid, CH3, COOH, formic acid, H2CO3, H3PO2, H3PO3, and boric acid, H3PO3. So all these are the examples of weak acids. Okay, so all these are the examples of weak acid. Clear? And arrhenius base. Arrhenius base. Sir, what is mean by the arrhenius base? Means here the substance which releases OH minus ions in aqueous medium is called as a arrhenius base. So what is mean the arrhenius base, ma? Arrhenius base is nothing but the substance which releases OH minus ions in the aqueous medium is called as a arrhenius base. Okay, here we have a two types of the bases are there. So one is the strong base. One is strong base. What are the examples of the strong base? All metal hydroxides, ma. Okay, all metal hydroxides are they act as a strong bases. What are the examples of the strong bases? Means NaOH, NaOH, KOH, rubidium hydroxide, okay, cesium hydroxide, CSOH, calcium hydroxide, CaOH taken 5. Okay, so all these are the examples of here strong bases. Okay, and which we can call it as a weak base. Weak bases. Okay, so what are the examples of the weak bases? Means we can take as a ammonium hydroxide. NH4OH we can take as a weak base. Okay, ammonium hydroxide we can take as a weak base. And aluminium hydroxide. Aluminium hydroxide we can take as a weak base. Zinc hydroxide we can take as a weak base. Iron hydroxide we can take as a weak base. Okay, so why we are calling as all weak bases means here because of the undergoes the partial dissociation. The substance which it undergoes the complete dissociations are called as here strong bases, and the substance which it undergoes the partial dissociation is called as a weak base. Now we got the clarity, all of you. Okay, and so one more definition also is there. So according to the Bronsted, so Bronsted also it has given some definition for the acid and bases. So which one am I here? Bronsted. Bronsted acid and bases. Bronsted acid and base. Sir, what is mean the Bronsted acid? So Bronsted acid is nothing but, okay, the Bronsted acid is nothing but here the substance which releases the H plus ion. That means proton donors are called as an acid according to the Bronsted-Lowry theory. So proton donor is called as a acid. Okay, according to the Bronsted-Lowry theory, proton donor is called as a Bronsted acid. Okay, and so proton acceptor is called as a proton acceptor is called base. Proton acceptor is called base. Okay, so Bronsted acid means proton donor is called as a acid. Proton acceptor is called as a base. Okay, sir. Now you got the clarity. Must tell anyone you having doubt. What are the examples of the Bronsted bases? What are the examples? Means ammonia NH3, water molecule, primary amine RNH2, ethyl alcohol, C2H5OH. So all these are the examples of Bronsted bases. Sir, how they accept the proton means on nitrogen atom they have a one lone pair of electron. If you see in water molecule, it has a two lone pair of electron. In primary amine, it has a one lone pair, and alcohol also it has here two lone pair of electron. That lone pair of electrons are they abstract the proton. So due to that reason only, all proton acceptors are called as a Bronsted bases. Okay, and what is mean by the Lewis acid? What is mean by the Lewis acid? So which we can call as a Lewis acid. So Lewis acids are nothing but electron acceptor. So which we can call as a Lewis acids means here electron acceptor. Electron acceptors are called as here Lewis acid. And electron deficient molecules also we can call as a Lewis acid. Sir, what are the examples of the Lewis acids means here? For example, BF3, BCl3, AlCl3. So all these are the examples of here Lewis acid. And Lewis bases, which we can call as a Lewis bases means here electron donors. Electron donors are called as a Lewis bases. What are the examples of the Lewis bases means here? And I'll give one more statement here. So what is another statement means here? All Lewis bases are they act as a Bronsted bases. All Lewis bases are they act as a Bronsted bases. But all Bronsted acid that does not act as a Lewis acid. Now you got the clarity. So what we can say means here all Lewis bases are they act as a Bronsted bases, but all Lewis acid does not act as a Bronsted acids. Now you got it here. Okay. Next. So we can go for another concept also here based on this one. So we have a conjugated acid base pair. It is conjugated acid base pair. Okay, let us see more. So what is mean by the conjugated acid base pair? Conjugated acid base pair. Conjugated acid base pair. Sir, what is mean by the conjugated acid base pair means here? If the, for example, I'm taking as a, first I'll give some examples. Here, I'm taking as a conjugated acid. Sir, what is the example of the conjugated acid means HCl. Okay, HCl. Sir, what is the conjugated base of HCl? Conjugated base of HCl means here that we can write as a Cl minus. Conjugated base of HCl is called as a Cl minus. Okay, conjugated base of HCl is called as a Cl minus. Now, if you see, conjugated acid and base are differentiated by. Okay, what is the difference it is there in between the HCl and Cl minus? What's the difference it is there in between the HCl and Cl minus?
Hydrogen.
One hydrogen, one proton. Okay, so in a conjugated acid and base are differentiated by one proton is called as a conjugated acid base pair. Okay, the conjugated acid and base are differentiated by one proton is called as a conjugated acid base pair. For example, sir, how they're asking the questions in the examination part means here. So what is the conjugated acid of H2, sorry, HSO4 minus? What is the conjugated acid of HSO4 minus? And what is the conjugated base of HSO4 minus? So you got my question, ma? So my question is here, I had given some conjugated base. Okay, with respect to the conjugated base, I'm asking as a conjugated acid. Okay, and with respect to the conjugated acid, I'm asking as a conjugated base. Now only you told that. So conjugated acid base pair means here. So if the conjugated acid and base pair are differentiated by one proton, means that we can call as a conjugated acid base pair. So what is the conjugated acid of HSO4 minus?
H2SO4.
Very good, Srita. Very good, man. So what is the conjugated acid means here? H2SO4 is the conjugated acid. Then what about the conjugated base of HSO4 minus? What is the conjugated base?
SO4 minus 2.
Very good, man. SO4 2 minus. SO4 2 minus. Because of by losing of the one proton, you will get as a one negative charge. By losing of the two protons means you will get as a two negative charge only now. Okay, so you'll get as a 2 minus. So that's why what is the conjugated base of the HSO4 minus means here HSO4 2 minus. Now another question, ma. So what is the conjugated acid of NO2 minus? Conjugated acid of NO2 minus.
HNO2?
Samgita is giving answer. Ma?
HNO2?
HNO2. Very good, ma. So conjugated acid of NO2 minus is here HNO2. Now we got the clarity. So this is about the conjugated acid base pair. So based on this one also, sometimes they're asking the questions in the MSET level examination. Okay, this concept is related to the MSET level examination. Clear? Right, man.
Yes,
In
sir.
recently, last in January session. In January session, based on this one, they asked the question in mains level also. Based on conjugated acid base pair. Based on conjugated acid base pair, they ask the questions in mains level also. Clear? And now we'll go for the degree of dissociation. We'll go for degree of dissociation. Degree of dissociation. Okay. Sir, what is mean by the degree of dissociation and at all means here? Let us see. So first of all, I'm taking as a acids. I'm taking as a some acid. So what is the acid I had taken means here HCl. If the HCl, if it dissolve in a water, it undergoes to the ionization and it forms as a H plus and Cl minus. Okay, I'm taking as a one acid. When the acid is dissolved in a water means it undergoes to the dissociation and it forms as an ion. What are the ions it is formed means here? H plus ion and Cl minus ion. Okay, at initial state, at a T time, T is equal to 0. The concentration of the HCl we can take as a C. What is the concentration of the HCl means here? C. The initial concentration of the H plus ions and Cl minus ions are 0. Okay, so because of at the initial stage of the reaction, there is no products. When the products are forming means here by consuming of the reactant. Okay, now after some time, after T time, okay, HCl is going to be dissociation. If it is dissociated means it forms as a the concentration of the H plus ions is equal to C alpha. Okay, and the concentration of the Cl minus is equal to C alpha. That means how much HCl is going to be consumed means here C minus of C alpha. Okay, how much HCl is going to be consumed means here C minus C alpha. So based on this one, so we are going to write the dissociation constant. So degree of dissociation constant. Degree of dissociation constant of acids can be represented with Ka. Okay, Ka also we can take as an equilibrium constant of the acids. Okay, this also we can call as here equilibrium constant of the acid, and this also we can call as a degree of dissociation of the acidic constant. Okay, this also we can call as a acidic constant. Okay, now so how you write as a equilibrium constant? Equilibrium constant is nothing but it is the ratio of the molar concentration of the products by molar concentration of the reactant. Okay, now what are the products it is there? H plus and Cl minus. H plus and Cl minus. H plus and Cl minus divided by so molar concentration of HCl. Molar concentration of HCl. Okay, now let us see in this one. Here Ka is equal to in place of H plus we can write as a C alpha into in place of Cl minus we can write as a C alpha divided by okay C into C minus C alpha. So finally we can write as here C into C alpha. Okay. Now if you simplify this one means C alpha into C alpha divided by. In this one, what is the common thing? It is the common thing is C only na. If we take the C is common means we can write as a 1 minus alpha. If the C is going to be cancelled means Ka is equal to, you will get as a C alpha square by 1 minus alpha. Okay, Ka is equal to C alpha square by 1 minus alpha. In this one, alpha is nothing but degree of dissociation. In this one, alpha is nothing but here, alpha is nothing but it is the degree of dissociation. Okay, so what is meant by the alpha ma? Alpha is nothing but here, degree of dissociation. Okay, for weak acids, actually this concept is we can apply for here. Okay, so weak acids and strong acids. At the same time, for weak acids, for weak acids, so degree of dissociation is going to be decreases here. That means, so alpha value is less than 1. Alpha value is here less than 1. So whenever it is less than 1 in denominator part, so alpha value is going to be negligible. If the alpha value is going to be negligible, then we'll get as a Ka is equal to C alpha square. So based on this one, we can derive the equation. So what is the equation we can derive means here? So we can derive the degree of dissociation equation. So how we can derive the degree of dissociation equation means here, directly I'm writing the formula. So alpha is equal to square root of Ka by C. Alpha is equal to square root of Ka by C. Already we know the molar concentration. Sometime in examination they're asking the molar concentration of the H plus ion. Sir, how we can calculate the molar concentration of the H plus ion means we wrote already one formula. Molar concentration of the H plus ion. Molar concentration of the H plus ion is equal to C alpha. You know the alpha value. If you substitute the alpha value means how will you get as here? So square root of Ka into C you will get. Okay, Ka into C you will get. So all these are the different formulas we are using the calculation part. Okay, and sir, you had taken for the acids. For bases also we can write the formulas also now. Kb. Kb how we can write? Kb is equal to C alpha square by 1 minus alpha. For weak bases, alpha value is going to be negligible. Then how we can write means alpha is equal to square root of Kb by C. Then molar concentration of the OH minus ion is equal to C into, okay, square root of Kb into C. So these are the different formulas we are using in the calculation part. Clear? Until here clear? If you're having any doubts.
No doubt, sir.
No doubt now? Then can I cover the next concept here? The next concept is we are having ionic product. Next concept we are having is here ionic product. Ionic product. Sir, what is mean by the ionic product? How you are going to represent the ionic product means here? Ionic product can be represented with Kw. Ionic product can be represented with Kw. So it is defined as, ionic product is defined as, it is the product of molar concentration of the H plus ion and molar concentration of the OH minus ions is called as a ionic product. So what is meant by the ionic product ma? Ionic product is nothing but here, it is the product of molar concentration of the H plus ion and molar concentration of the OH minus ions is called as a ionic product. Okay, so in this one, at 25 degrees centigrade, at 25 degrees centigrade, Kw is equal to, okay, 10 power minus 14. Ionic product value it becomes as a 10 power minus 14. If the temperature is increases, the temperature increases, Kw value increases, ionic product value also is going to be increases. Now we got the clarity. Okay, so now you got the clarity ma. So based on this one we can write one formula also. 25 degrees centigrade, molar concentration of the H plus ion is equal to molar concentration of the OH minus ion, okay, is equal to 10 power minus 7. 10 power minus 7. Okay, so 10 power minus 7. Based on this formula also, sometimes they're asking some questions. Okay, that is also you can check it out. Okay, next we'll go for salt hydrolysis. We can go for here. Salt hydrolysis. Salt hydrolysis. So what is meant by the salt hydrolysis? Sir, before that one also we have one more concept also after the ionic product. So what is the product concept we are having after the ionic product means here? So pH it is there, one concept. What is meant by the pH ma? Calculations are there ma, that's why I got it. Otherwise, pH it is there. So what is mean by the pH? What is mean by the pH? So pH is nothing but negative log of molar concentration of H plus ion is called as a pH. Negative log of molar concentration of the H plus ions is called as a pH. The term pH is introduced by Sorensen. The term pH is introduced by Sorensen here. Okay, so these also we can write log of 1 by H plus also we can write. Log of 1 by H plus also we can write. Okay, actually pH values are in between 1 to 14. 1 to 14. If the pH values are 1 to 6 means that we can call as a acids. Okay, that we can call as a acids. Actually here pH and molar concentration of the H plus ions are inversely proportional. pH and molar concentration of the H plus ions are inversely proportional. If both are inversely proportional means here what happen if the molar concentration of the H plus ions are increases, pH value is going to be decreases. Due to that reason only, strong acids are having low pH value. Weak acids are having high pH value. Okay, if the pH value is equal to 7, if the pH is equal to 7, if the pH is equal to 7 means then the given solution is it becomes as a neutral. Then the given solution becomes as a neutral. If pH is equal to 8 to 14 means that it indicates a base. pH is equal to 8 to 14 means that it indicates a base. Okay, so based on this one also sometimes they're asking the questions in the say set. Okay, K-set, M-set level examination. Okay, CET level examination, they're asking the question here. So what is the next one? Next one is nothing but salt hydrolysis. Salt hydrolysis. What is mean by the salt hydrolysis? What is mean by the salt hydrolysis means here? Dissolving of the salt in a water is called as a salt hydrolysis. What is mean by the salt hydrolysis here? So dissolving of the salt in a water is called as a salt hydrolysis. So we can give another definition also. So what is the another definition we can give means here? Salt hydrolysis is exactly opposite to. So neutralization of the acid base is called as a salt hydrolysis. Okay, what is another definition we can give? It is the reverse reaction of acid base neutralization also we can call as a salt hydrolysis. Sir, how you are telling them like that means here? Because of I'll give one example. So what is the example means here? For example, aqueous solution of the base it is that NaOH. If it is treated with the aqueous solution of the HCl, if it is treated with the aqueous solution of the HCl means it forms NaCl plus H2O. Okay, in this one NaCl is the salt. It is water. So acid base neutralization means it forms as a salt and water. Okay, if you take the reverse reaction, if you take the reverse reaction means that we can call it as a salt hydrolysis. Okay, so we have different types of the salts are there. We have different types of the salts there. Acidic salts. Acidic salt. So what is mean by the acidic salts means here? The salts which releases the H plus ions is called as here. So acidic salts. Okay, that means the salt which contains replaceable
Sir, I have a doubt.
Yeah.
So that means converting the salt back into HCl and NaOH is salt hydrolysis.
Yes, ma'am.
Okay. Okay.
Like reverse reaction we are taking. Okay, so we have a different types of the salts. What are the different types of the salts are there means acidic salts are there. What is mean with the acidic salts means here? The salts which contains the replaceable H plus ions is called as a acidic salts. What is meant by the acidic salts, ma? The salts which contains replaceable H plus ions is called as a acidic salt. What are the examples mean? Sodium bicarbonate, NaHCO3. In this one, we have a one replaceable hydrogen here. Okay. And sodium bisulfate, NaHSO4. Here also we have a one hydrogen here. Sodium phosphate, NaH2PO2. In this one, we have two hydrogens here. Okay. NaH2PO4. Okay. So like this here, all these are the examples of acidic salt because of they contain replaceable H plus ions. Okay. And we have a basic salts. We have a basic salts. Sir, which we can call as a basic salts means here the salts which contains replaceable OH minus ions is called as a basic salts. The salts which contains replaceable OH minus ions is called as a basic salt. What are the examples means? For example, calcium, CaOH twice Cl. Okay, this is the one salt. Zinc hydroxide, zinc OH and Cl, and aluminum, AlOH taken twice Cl. So all these are the examples of the content here. One replaceable OH. Okay, so all these are we can call as a basic salts. All these are we can call as a basic salts. Okay, and double salts also it is there. What is mean by the double salts? What are the examples of the double salts? It we can call as a double salt. You have done some practicals. What is meant by the double salt? When you are having CET exam, when you have KSET exam, KSET or MSET, Samhita, Shrita.
In the first week of May.
First week of May. Okay, along with the NEET. So you can write NEET also, at the same time you can write MSET also. May 5th is the NEET exam. I don't know how many members they are preparing for the NEET. Niharika, hope so Niharika is preparing for the NEET. Is it right, Niharika? What about Ma? So what is the example of the double salts? Ma, MSET questions only I'm asking. CET level questions only I'm asking. Ma. What are the examples of the double salts? So example of the double salt is more salt. More salt. What is mean the more salt? You have done the practicals now. KMnO4 versus FAS. Ferrous sulfate and ammonium sulfate. FeSO4 and NH4 taken twice. SO4 7H2O is called as a more salt. Okay, I didn't remember exactly number here, number of water molecules here. So either 7 or 6. Okay, so second. Till now. Right, 6H2O. More salt is here. It is 6H2O. What is a molecular formula means here? And FeSO4, FeSO4, HRS, more salt. So what is the molecular formula means? FeSO4 and NH4SO4, 6H2O is called as a more salt. More salt is the example of double salt. Okay. At the same time, carnallite. Carnallite. What is with the carnallite? KCl, MgCl2, MgCl2, 6H2O is called as here carnallite. Okay, and potash alum. What is the example of the, what is the molecular formula of the potash alum? K2SO4, Al2SO4 taken 3 times 24H2O is called as a potash alum. All these are the examples of the double salt. All these are examples of double salt. Sir, why we are calling as a double salt means when they undergoes to the ionization, they releases the 2 cation. How many cations they are releasing? They releases 2 cations. That's why we can call it as a double salt. If the salts also it undergoes to the hydrolysis reaction, so we have a dissociation constant, okay, and degree of hydrolysis also it will be there. Okay, degree of hydrolysis also it will be there. Hydrolysis constant also it is there. Okay, so based on that one also we can calculate pH of the solution. Okay, so based on this one, so we can calculate pH of the solution also. So whatever the salts are there, it is forming based on the nature of the acid or base. For example, you have taken strong acid, strong base. If the salt is formed by strong acid, strong base. Okay, then whatever the nature of the solution, it becomes as a neutral. Nature of the solution becomes as a neutral. Then whatever the hydrolysis constant, that means KH value. KH value won't be there. Okay, and degree of hydrolysis. Degree of hydrolysis can be represented with H. H also it won't be there. Then what about the pH? pH also it never be changed. pH it becomes as a constant. Okay, next one. If you take weak acid, strong base. Weak acid and strong base salt. Weak acid, strong base salt means the resulting solution it becomes as a base. Okay, then what about the KH? KH value means here KH is equal to KW by KA. KW by KA. Okay, and hydrolysis constant. And what is the pH? What is the pH of the resulting solution? Formula means here 7 plus 1 by 2 pKa plus 1 by 2 log C. So based on this formula, we are having some of the calculation. Okay, and second one, next one, strong acid and weak base. Strong acid and weak base. If the strong acid and weak base means the resulting solution it becomes as an acidic nature. The resulting solution becomes as a acidic nature. Then hydrolysis constant value is equal to Kw by Kb. Kw by Kb. Sir, what is the hydrolysis constant here? Degree of hydrolysis means degree of hydrolysis is equal to square root of Kh by C. Square root of Kh by C. So what is the formula we are using to calculate the pH value means here 7 plus 7 minus 7 minus 1 by 2 pKb minus 1 by 2 log C. Okay, and what is the another salt means here? Weak acid, weak base salt. Weak acid, weak base means the resulting solution becomes as a neutral. Okay, sorry, the resulting solution may be acidic or basic, maybe acidic or basic, maybe acidic or basic. So based on that one, hydrolysis constant, how we can write means KH is equal to KW by KA into KB square root of KH. Then what is the formula we can write as a pH means here pH is equal to 7 plus 1 by 2 pKa minus 1 by 2 pKb is the formula. So these formulas are very, very important. So where we are using means the calculation part, they are asking the questions. Okay, this is about salt hydrolysis. Okay, next we have one more concept, buffer solution. It is buffer solution. What is meant by the buffer solution? Do you have any idea about the buffer solution? Buffer solution. Sir, what is mean by the buffer solutions means the solution which does not change the pH of the acid or base. Simply, I'll tell one thing. First of all, I'm taking as a some dilute HCl. I'm taking as a some dilute HCl. In the dilute HCl, okay, so I think so. Everyone you knows the pH of the acid dilute HCl. What is the pH of the gastric juice, pH of the gastric juice, everyone knows. pH of gastric juice. Gastric juice is nothing but here HCl. The pH of the HCl is, it is 1.5 to 2 it will be there. Okay, what is the pH means here? It is 1.5 to 2 it will be there. So for that only if you add some acid, excess of acid, if you add some concentrated sulfuric acid means pH value is going to be decreases. Otherwise if you add pH values base means, if the base means if you add this pH value is going to be increases. Okay, that means whenever you add some excess of acid, some excess of base means pH value is going to be changed. To overcome that one, we are adding some solution. The solution which prevents to change the pH of the solution by adding excess amount of the acid or base is called as a buffer solution. After adding this one, if you add excess of acid also, or if you add excess of base also, the pH is not going to be changed. That kind of solutions are called as here buffer solution. Okay, sir, we have two types of the buffer solutions are there. So what are the two types of the buffer solutions we are having means here? One is acidic buffer solution. Acidic buffer solution. Second one is basic buffer solution. So what are the examples of the acidic buffer solution means? Acidic buffer solution is containing weak acid and the salt of so salt of weak acid strong base. Okay, it contains here weak acid and salt of weak acid and strong base. Weak acid and strong base. Sir, what are the example for this one means here? What are the example means acetic acid? CH3COOH plus CH3COONA. So what is another example of this one means here? Sodium carbonate, sodium bicarbonate, NaHCO3 and Na2CO3. Na2CO3. Okay, Na2CO3. Sorry, H2CO3. 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 So it is an example of here. In this one, weak acid and salt of here. So weak acid, strong base. So here they had given one formula. That is only we can call it as here Henderson equation. Henderson equation.
So what do buffer solutions do again? What do buffer solutions do?
Buffer solution does not change the pH. That is only I'm telling that here. Okay. So for any solution, actually, milk is there. Milk is there. Okay. If you milk means when it keeps for the fermentation process means, when it keeps for the fermentation process means it is converted into the curd now. It is converted into the curd or not, Samhita?
Yes, sir.
Okay. So after that, if we leave for a long time means, okay, the taste is going to be changes.
Yes.
Curd taste is going to be changes or not?
Yes.
At the same time, it gives some smell also. Okay. Why it is the taste is going to be changes and why it causes some smell? That means it's keep on undergoes to the fermentation process means acidic character is going to be increases in the curd. Okay, acidic character is going to be increases. If the acidic character means it gives us some sour smell or something you are getting here. Okay, but for that one, if you add some pH value buffer solution means, okay, it won't change the pH. It won't change the pH because of whenever it is changes means taste and all means pH value also is going to be changed. Okay, for that one, if you add any buffer solution, for that one simple example I'll tell. Actually, in home, if you prepare the curd means if you keep 1 or 2 days means it's going to be spoiled. Is it right? It's going to be spoiled or not?
Yes, sir.
Okay, but we are getting cod, we are purchasing cod from the shops. If you see in shops, means whatever the cod it is that they're going to be stored 2 to 3 days also. It is stored 2 to 3 days also. So why after 3 days also the taste it will be constant only? Why the taste is not going to be changed which with the cod we are getting from the shop, but the cod which is preparing at home it is going to be change the taste. What is the reason? What is the reason? They're adding some chemical substance, okay, so they added some buffer solution also. If you add their buffer solution, they maintain the pH is constantly. That's why taste is not going to be changed after 2 days also. Okay.
Yes, sir.
Right, ma. So what is the Henderson equation of the buffer acidic buffer solution? Means pH is equal to pKa plus log of salt by acid. Log of salt by acid. Okay. Similarly, basic buffer solution. Basic buffer solution. Sir, what is meant by the basic buffer solution? Means it is also basic buffer solution means it is the mixture of weak base plus weak base and strong acid salt. Strong acid salt. What is the best example? Means ammonium hydroxide plus ammonium chloride and H4Cl. So for this one also we have a Henderson equation. What is the Henderson equation? Is POH is equal to pKa plus log of pKb log of salt by base. Salt by base. Okay, if you know this one means from this one, if the POH, if you know means from that also we can calculate the pH value. Sir, how we can calculate means pH plus POH is equal to 14. If you substitute the values means based on this one, we can calculate the pH value also. So all these are the formulas we are having for examination part. Buffer solution also it is one of the important concept. Clear? And the remaining part will continue tomorrow. Okay. 19.5% it is finished. Only one concept pending it is there. Only one concept pending it is there. So chemical equilibrium is completed. Okay. So remaining part will continue in the next class.
Okay, sir.
Okay, ma. So we'll see you in the next class. Thank you all.
Thank you, sir.